I would like to welcome you all. My name is Hanna van den Bos. I'm a program creator for Studium Generale, and we organize all kinds of events like this one. You can also see some that we have coming up in the back here. Oh, it's not working. It should be working. Wait. Yeah, ta-da. So you can see some of our upcoming programs here also. We do a lot on current and urgent themes, but we also have lots of culture events like SG Music. So yeah, I would advise you to have a look at our website. And for students, it's especially interesting that we also have a SG certificate. You can visit 5 of our events, then write a small reflective report, not a summary, reflective report, and then you can get that certificate. More information can be found on our website, or you can come up to me as well afterwards. So, then to today's topic. Many of you probably have heard the news, I believe it was in June, when the Dutch RIVM published a report that Dutch people have too much PFAS in their blood. And recently there's also lots of discussions going on that the food that we eat may contain too many pesticides, making it potentially unhealthy. But what is actually true of these claims, and how unhealthy are these toxins truly? These are questions toxicologists have to deal with every day. So in this lecture, I'm really glad that we have a renowned toxicologist here today, Martin van den Berg. He explores both the science behind PFAS, pesticides, but also the broader field of toxicology. So he will also go into how toxicologists work behind the scenes, you could say, to keep you all safe. Professor Martin van den Berg is emeritus professor of toxicology at Utrecht University. He is also an author of more than 375 scientific publications, and he has advised WHO, FAO, the EU, and also US committees on environmental toxicology and chemical safety. So please give a big applause for him.
Well, she already introduced me. What I'm going to do here is I'm going to split the talk up in actually 3 parts. One part is that I'm trying to explain you how we work, what we do, how we try to keep you safe from all kinds of things. It's a kind of rules of engagement, let's call it like that. Then I zoom in on PFAS and I zoom in on pesticides as 2 case studies in which I'm personally involved one way or another. Now I realize that probably most of you don't have a nature, science background, but a bit different. So if you, normally I talk also for biomedical students or something, and I did my best to make it a bit more general. If it's not general, don't hesitate to ask me anything, but let's save the discussions for the end, okay? Just for clarification, don't worry, just ask the question if it's not clear for you because of your background, which I can imagine, okay? Okay, so this is who I am. Yeah, here. Now, one of the first things I like to tell you is that the biggest problem for toxicologists is not actually the sensitivity of species and the research which we couldn't do, but it's actually coming from the chemist who can detect very, very little amounts. And this is something which I like to give as a take-home message for you later on, that if you measure something and it's extremely small, that doesn't necessarily mean that there is something wrong, that there are adverse health effects or something like that. So that's why this famous chemist toxicologist said, the problem is not the toxicologist, but the problem is the chemist, because they can measure less and less amounts, smaller amounts. And you have to remember that at this time, Normally, if you want to have a lab with normal chemical analytical equipment, 10 to the minus 12, which is 1,000,000 from 1,000,000 gram, must be easily detected, which is extremely small. It's getting somewhere in the area of 1 bacteria or DNA in a cell or something like that. Doesn't mean it's dangerous. Now, the first toxicologist actually there was around 15th century, and he had a very clear view on that already, because what he basically said is the dose makes the poison. Yeah? In practice, everything is, you can kill some organism with almost anything. Yeah, but then I got exactly I can stand there if you want.
Yeah, sure. Yeah.
Can you?
I can do this.
Because this is really blinding.
Is this better?
No, it's still there. So I stepped out of. Yeah, now it's getting better. Okay. So, Paracelsus, first toxicologist, said the dose makes the poison. Yeah, that's the bottom line. If you go home tonight and you think, okay, this guy at least tried to explain me that the dose makes the poison and I shouldn't panic any time they say I measured something and it's in the newspapers, I've done my job in this respect. If you look at risk assessment, how toxicologists do that, it's a very simple scheme. First of all, we have two different things which we recognize. Hazard. And hazard is actually something like, let me put it this way. If you're swimming, there may be a shark, but the shark may be 50 kilometers away. It's still a hazard because it can eat you, it can bite you. If it's getting within a couple of meters, you may be at risk, because that's the difference between hazard and risk. Hazard is the property of a chemical that it can do something at a specific dose, while the risk is actually, at that particular dose, what kind of effects do you get? So the dose makes the poison. Dose-effect relationships. Really important for me to have a view on that, because I want to know if at a certain dose level I can expect anything for especially humans in this case, but we do that quite often first with animals. Identifying the risk, high priority. From there on, I take a step back and I say, okay, I've done my job. I go to the government, I say to the government, I don't like it, or I do think that there are no risks, and the rest is actually policy and politics. It's the measures to limit the risk, and in some situations the government can say, okay, we accept the risk. If you go to a petrol station and you tank the petrol, you will inhale what they call benzene. Now, benzene is associated with leukemia. If you want to, I can calculate what the risk is that you get leukemia from going to a petrol station and tanking petrol. It's very small, by the way. The government accepts the fact that 1 out of 1 million or 1 out of 10 million people may be at risk to get leukemia. Because if they stop selling petrol, we have a huge economic problem, and that's policy and politics. I stay out of that. Communicating, in general, is the situation which is expressed by the government, although toxicologists, including myself, nowadays also communicate risks and say in the press, for example, or on television what they think, because quite often the government is very much influenced by politics, and politics fluctuate in the Netherlands every 4 years. Okay, so you got all kinds of chemicals, and within the European Union, there's one group of chemicals. Let me see if it works, the pointer itself. I think so. Yeah, here it is. I want to zoom in on this group, which is a group which they call, in this case, substances of very high concern. And PFAS compounds, and it was just already mentioned, is considered to be a group of substances of very high concern within the EU countries, while pesticides could be hazardous, could be a risk, but it depends on a lot. It depends what type of pesticide, it depends your life stage. Are you a child? Are you a pregnant woman? Are you an elderly? Or are you an adult, healthy person? So, when I talk about substances of very high concern, a kind of rule of thumb is that I say, okay, don't wake me up if the dose level is higher than 10 to the minus 6, 1 millionth or higher. Around 1 billion, a milliard, gram per kilogram body weight per day, if it does anything at that dose level, I'm getting interested, to tell you the truth, for substances of very high concern. One of the priority substances in which we have to be dangerous, like PFAS, or in which we have to think about limiting the exposure. For pesticides, it's much more complicated, you will hear that. What is a substance of very high concern? It's a substance which can cause cancer. It's a substance which can be mutagenic, and I don't know if you all know what mutagenic actually means, but if I say it's simple, it changes something on the DNA, and to tell you the truth, the color of your eyes may be influenced by something changing on the DNA, and that could be mutagenesis, but the mutagenesis is very innocent, usually very innocent. But mutagenesis itself can eventually lead to cancer. Toxic for reproduction, extremely important because nowadays, and you may have heard about it, endocrine disruptors, hormoonverstorende stoffen in Dutch, have been an issue for the last 10, 20 years because the European Union, unlike North America, likes to focus and zoom in on limiting the risk of these type of compounds which causing effects of reproduction and the developing fetus and embryo. Furthermore, it should be persistent, accumulate in the food chain. In other words, through the food it may reach you, like PFAS does, like some pesticides, which eventually end up in the food and you will ingest it by eating or drinking for PFAS. Bioaccumulation is that it builds up the higher in your food chain, the more you will see in an organism, and don't misunderstand this, you're at the top of the food chain. Yeah? If you look at breast milk and you look at persistent compounds like dioxins, like PFAS, levels in breast milk are much higher than levels, for example, lower in the food chain in fish, because you're at the top of the food chain and you accumulate it. And of course, it has to be toxic. The general rule is that, unfortunately, we still do experiments with animals. What I actually say is, okay, humans are animals, but it doesn't mean that animals are humans. So there is a difference, a species differences. And what you then actually do is, as a toxicologist, you look at animal studies, and nowadays you also look at cell studies to reduce the number of animals. You apply safety factors, which is usually a factor 10, and I won't bore you with why it's kinetics or dynamics, from rat to healthy humans, and you put another safety factor 10 here for all kinds of groups which may be more sensitive. Children, pregnant women, elderly. Altogether, a kind of standard approach is, if you look at your animal studies and you see the toxicity of a kind of chemical, you put a safety factor 100 there. In other words, if you would see no effect in the animals at 100, you have to divide it, and a product which has that chemical will not be allowed to have a higher exposure than 1, because you divide 100 by 100. And that's the safety factor. This safety factor 100 is the standard approach. It could be more, it could be less, but if it's less, especially less, I have to give strong motivations as a toxicologist in FAO, EU, WHO to say, I think we can do with 50. But I have to have good arguments for that. Okay, like I said, humans are animals, but animals are not humans. And that's the difference between rats, man. Monkeys get closer, but monkeys, really, we should stop with that. We better bring in some safety factors instead of doing monkey experiments. So nowadays, monkey experiments are rarely done, and it's usually the last stage in developing vaccines. For COVID, for example, because then it's the only species before you can go to humans without killing possibly humans. That's unfortunately still the situation, but animal studies are more and more brought down by toxicologists because in the initial state, they do all kinds what they call in vitro tests with cells. They have computer modulation, and by doing that, they reduce actually the early stage of testing a chemical, and with that, reducing the number of animals. But don't misunderstand, we cannot work, unfortunately, totally without animals at this stage. It's just not possible. We're not clever enough. Like I said, the dose makes the poison, and this is just one more illustration quickly for you to see. Here is an animal experiment, but you may replace it by a cell system with computer modulation. Then you get the factor 10. In other words, your dose-response relationship divided by 10, and another time, so you end up for the whole population, and you call this an acceptable daily intake. And that is what we, with our knowledge, which isn't perfect, but at least we try, say if you get anything below the acceptable daily intake or on the acceptable daily intake, my estimation as a toxicologist is that you have a very, very limited risk to develop cancer, to have reproduction problems or problems with the developing fetus, etc., etc. Okay. One of the serious things about toxicology nowadays is that we are thinking that quite a number of diseases are actually plugged in during what they call the pre- and the postnatal period. In other words, the early life stage. And why? Because at that point, the DNA is working continuously to make separations. Early stage, what becomes kidney, liver, arms, head, brain. And further on, it has to grow. And because this extensive growth of all kinds of organs and limbs, we have a very sensitive system, because a cell can only grow if the DNA opens up. You may remember that from high school. It goes open and then it divides in one cell in two cells. That is a critical situation. If there are chemicals around, they can disturb the DNA when it opens up, and you will have a problem. So nowadays, we're very much focused on this early life stage situation. And for me, it's called, in Dutch, stokpaardje. It's one of the things which I personally think is very, very important for PFAS, for pesticides, etc. And they have a kind of theme for that, and they call it the developmental origin of health and disease. It starts in the beginning. What do we mean by that? A chemical exposure, either as a fetus or a baby, can cause eventually all kinds of behavioral and developmental problems, like autism. It can also give all kinds of neurobehavioral aspects, a lower EQ, concentration problems, etc., etc. When we go further on, late in puberty, all kinds of chemicals can disturb the hormonal process, why eventually you become, from a child or a baby, an adolescent, puberty, into an adult, which isn't anything more than being just ready for reproduction, because that's what's actually happening in puberty. This is a sensitive process, and then later on you can see that back in reduced fertility, and nowadays this is a problem because a lot of couples, young couples, don't get children that easily. And in vitro fertilization is a kind of common practice because of these problems, and we don't know why, but it could have something to do with our modern society in which we're exposed to quite a few chemicals. But to tell you the truth, solid proof is still lacking. And eventually, later in life, you may develop cancer, cardiovascular diseases, diabetes, and Parkinson. I'm going to talk about that later with pesticides. So Paracelsus was right by saying the dose makes the poison. But if he would be living now, and he and I would communicate, he would probably say, you're absolutely right. And the other thing which I would say now, it's the timing of the dose during the life that makes the poison. Because you can be a very healthy person, male, female, 40, and have no effect at all of a certain exposure to a chemical. While a pregnant woman, a fetus indirectly, by transport across the placenta, or a baby, because of fruit with certain chemicals on it, may have a very higher sensitivity. In other words, at lower dose levels, you may eventually have an effect of this chemical. So please remember that the life stage is also important. Not only the dose makes the poison, but the life stage, and it goes back to the early life stage, which seems to be the most important life stage, except for the elderly, because then when you really get old, 70, 80, 90, a lot of defense mechanisms of your body are becoming less active. And that's why some people sometimes say, cancer is an old people's disease. Yeah? Why? Because probably if you're an adult, you're hit on the DNA by chemicals which you get from outside are thousands a day. But your defense mechanisms in your body are still optimal. And once you're 40, 50, 60, 70, 80, it's getting less and less. And when then it deranges the DNA, it eventually may lead to a tumor. And that's why you see much more cancer in older people than in younger people. That doesn't mean it doesn't exist in younger people, but it's rare. Okay, one of the things which you may heard, and I think you know a little bit of statistics or something. Sometimes you hear RIVM has calculated that in that particular situation, 1 out of 100,000 people may develop a tumor, cancer of the bladder or the liver or whatever. And this is a very interesting phenomena because toxicologists have a theory. It's a theory because it's so difficult to measure, that if you have a chemical which responds directly on your DNA, and suppose this is the DNA, and this chemical, you get it through your food, it gets into your intestines, it's taken up in the blood, it's brought to the kidneys, for example, and then in the kidney cell, it hasn't been eliminated, it hasn't been killed, if you want to say it like that, it connects to the DNA, and you only need one molecule to, let's say, dearrange that cell. And then, for whatever the unclear reason is, the cell starts to divide, and what do you have? A little lump, which they call a tumor. Now, some of them, at some stage, are eventually starting to migrate in the body. And that means that they can spread into the body, and you have cancer. So, and they say, okay, one molecule can do the job, and what we then do is we do an animal experiment, and we take one straight line back to zero. In other words, one molecule can cause one cell to cause a tumor. You do the calculations, and forget all the calculations behind it, and then you end up, based on the results from the animal experiments, that 1 out of 100,000 people or 1 out of 1 million people may develop tumors. That's important to remember. That's another group of compounds, and that's when you hear there is a risk 1 out of 100,000 or 1 out of 1 million. They call it quantitative risk assessment. In the other situation, we just try to stay below the level in which any effect is seen, a threshold, before the curve goes like this. 2 different types of chemicals we have to work with. Okay, we talk about carcinogenicity now. And carcinogenicity, and I've been a member of IARC for decades. I'm chairing plenary sessions also from IARC, in which IARC is the International Agency for Cancer Research from the World Health Organization. And if you look at it, how they do it, and I'm not going in too much detail, basically they have 4 categories. One is, we're sure it causes cancer in humans. The other one is probably, or possibly, or not. Well, being sure is an easy case. Possibly or probably is, let's say, the difficult one, because probably is heavier, especially from a legal point of view, than possibly. So we have to make a decision, and what's actually happening is they just bring you to Lyon in France, and there's a big building there, and you have an expert group, and these people are not your friends, believe me, and you stay there for 10 days, you're locked up, and you give, for example, a group of 10, 20 compounds to evaluate. And at the end, there has to be something, it's almost like choosing a pope, white smoke or black smoke or whatever. And that's eventually then group 1 to A to B, etc. And we combine all the information together. Epidemiology, meaning that what has been seen in the population, animal studies, what type of tumors are we seeing, and which are the tumors which we are actually seeing in humans. In animals and humans are the same. And the third one is the mechanism in which such a chemical works, relevant for humans. To tell you the truth, the last one is my specialty. To say something, what I see in the rat, is that from a mechanistic point of view, comparable what humans can get. Okay. One big misunderstanding is that you get cancer, and it also comes back to PFAS and pesticides, from the environment. And this is interesting to know because this is 2006. It's a joint activity by the World Health Organization, the International Agency for Cancer Research, and the American Cancer Society. And they made extensive calculations. And what I like to show you here is that this little brown area is actually, this is the total population. Where do you get cancer from? Direct environmental pollution is only a very small part. Occupational risk is still there, but you can do a lot about it by protecting the laborers. Diet and nutrition is much higher. It's 30%, in which especially obesity is a very important signal for cancer later in life, because it also is related to exercise. And it seems to be that if you have enough exercise, it reduces both your fat amount as well as the risk on cancer. And then interesting enough, from the total amount of cancer, 16% is still caused by smoking, which is actually we can avoid. But it's a significant amount still. And we talk about a little bit less than 100,000 people a year in the Netherlands only. Meaning, and in some areas like Africa or Asia, it's even much higher. So the big misunderstanding here is that we get a lot of cancer from the environment. That's not true. We get it from food, diet, our lifestyle, including smoking, but not environmental pollution. That doesn't mean you don't get anything, but it's in the total picture less quantitative significant. This was a study I worked on with TNO and the KBF, the Cancer Foundation in the Netherlands, and it just illustrates again what is important, and I'm not going too much in detail, but this is smoking. And you see contributions of the smoking, again 16%, and that was about 2 years ago in this big report. And then unhealthy diet, second, overweight, quite close to each other. Alcohol, it's there. But it's, okay, I don't promote alcohol here, but I mean, it's less than some people think. But it's still there. For example, for women, there is an increase in getting breast cancer if they drink too much. And they've made calculations, one of my PhD students, and they say, well, if you drink 1 glass of wine a day, as a woman, you may be roughly in the area in which there is no additional risk. If you go much higher, eventually you may have a risk, but to tell you the truth, you can never pinpoint a certain person. You always work in groups, in sizes, you know. It's a society you look at, not individual calculations. It's statistics. So here you see the smoking in the Netherlands as an important one, about 20,000 diagnoses, the 16%. Sun exposure, and actually this is a bit rough, because here you got 3 types of tumors, and unhealthy diet are mentioned. One of the other things is meat. Red meat, it's not mentioned here, and prepared meat, sausages, etc. If you eat them too much, we know that there is an increase in tumor incidence in the population. Now PFAS, let's go to the second part. PFAS was already mentioned, and you've heard about it probably before. It's not going very well with PFAS exposure in the Netherlands for humans. And we have a couple of companies which have been using PFAS or are still using a certain type of PFAS. Chemours, of course, in Dordrecht, and then 3M, which is close to Antwerp. And those are the big producers, but there are probably more. But we don't know that, because funny or not, or alarming or not, I should say, the Dutch government is not registering this very carefully, except for these two big companies. So there could be a lot of small companies which are actually importing a specific PFAS. We got thousands of them. And we have no clue how toxic they are compared with the ones which were produced by these two big companies. So PFAS itself, it's everywhere. It could be on your mascara, it could be old clothes, because it's excellent for waterproof, but it's mostly known from Teflon. And this is an interesting toxicological problem, because if you ask me, is a Teflon pan actually unhealthy? I would probably say no. Because once you make Teflon from PFAS, it sticks together and there is no PFAS coming from the Teflon pan. But if you don't use a Teflon pan, it may very well be that you burn your food, the little black crusts, etc. And in these crusts are really carcinogenic compounds, which cause cancer. So it's pretty strange that from a product like PFAS, there is a product like Teflon pans, which actually reduces the exposure to carcinogenic compounds from food frying. And so it's a bit double in this case, and the PFAS compounds are usually a starting product from something. They're never PFAS itself, which you have on your clothes, in your food, or in cleaning products. It's used for something to make further on the line. It's a very complicated cycle. And one of the things, and that's the only thing, because here you got, this is a big tree, and you have to think there are thousands of them somewhere in there. And there are only 2 of them which are for the Netherlands, 3 maybe, for the Netherlands very relevant. And for those of you who had some chemistry in the end, and this is probably the only structure I'm showing you, is that this is an interesting chemical because why this part of the chemical is actually not water soluble, and this part here is soluble. That makes the compound very, very nasty for a toxicologist because besides accumulating in food, in the fat of animals, in eggs, because we're getting to that later, you see clearly an increase, but it's also in the drinking water because of that property that it's also water soluble. And so it's a two-edged sword, water soluble as well as lipid soluble, fat soluble. And in the past, compounds like DDTs, PCBs, dioxins, brominated flame retardants, they were always not well soluble in water, but very soluble in fat, meaning that they were actually accumulating. And in women, for example, they were accumulating here during their life stage until they start breastfeeding. And when they start breastfeeding, they produce something which has roughly 5% fat. And they transfer that to the baby. We've seen that if you build up your fat residues of dioxins or PCBs with your first child, you can approximately give 5% of the dioxin, PCB type of compounds, DDT, which you build up during 25 years as a female. In the second child, it's a little bit less. It goes less and less the more you get. So it's a very effective way for women to get rid of it, while men can't get rid of it, and it's just accumulating and accumulating. Luckily, these levels are going down and down. But we now have the more modern compounds like PFAS, and of course all kinds of pesticides, which may eventually cause some health problems at some dose levels. Well, this is the whole cycle, how it ends up in water, food, etc., and I guess you believe that. If you look at PFAS itself, then, and normally I use a little bit of magnifier here, but there are a couple of things which PFAS does. First of all, it influences the thyroid, which is extremely important for growth. Then it influences the cardiovascular system with cholesterol, renal damage. The endocrine system, the ovaries and the testes are affected. And then eventually development during pregnancy, etc., and influence on the hormone. In other words, it's extremely complicated. And it gives me a headache. I'm chairing the task force of the World Health Organization for the next 2-3 years in 3 stages for doing a kind of global advice for what would be the acceptable daily intake. But because we have thousands of chemicals and we have all these different effects, we have to figure out what's the most sensitive one, where should we put emphasis on to restrict exposure, and then say, okay, maybe that one should be taken off the market. But it's just an advice. WHO always advises. It can't say to the Netherlands, take it off the market. That's politics again. So it's a very complicated group of compounds, and eventually, I skipped this one. This is, sorry. What you actually see here is the following. I hope you can read it. It's a scheme, and this is kidney, skin, eye, hormonal, immunological effects, resistance, immunoresistance, neurological effects, reproductive effects, and developmental effects. These are all studies which have been done with different kind of animals, but there are also human data in there, and this cluster is really important, developmental. And you see the same cluster here for another PFAS compound, and by putting then the safety margin, the safety values on it of a factor 100 or more, you end up somewhere here, and you conclude that, okay, I don't think it's wise if you have a lifetime exposure to 10 to the minus 9 gram per kilogram body weight per day. That's 1 billion gram. And that's based, if you see it here, on a very extensive group of experiments, including some human epidemiological studies, and it's more or less the same here, except for this compound there's also something in which we see the immuno effect, and that's also a bit scary, because if you give it to children in the first 1 to 5 years of life, it turns out that all kinds of vaccines against children's diseases are approximately 20 to 30% less effective. So there's a reduction in the activity of the vaccine, meaning that it works. And if it works, that's not good. You don't want to have something that works like that. So these very low levels eventually end up with this egg problem in the Netherlands. But there is justification for that. It's not because there is a political group saying it has to be taken off the market. No, it's the toxicologists and the risk assessors from the government who agree on that PFAS compounds really have a very low level in which you should be exposed to. This is just to quickly show you how the vaccine effect works. This is epidemiology, and if it's green, there's nothing going on. It's 0. And what you see here, you got mumps, measles, influenza, rubella, tetanus. In other words, all these nasty children's diseases they can get. And all these averages, which you see, are on the left side, meaning you got a reduction 20 to 30%. And this is one PFAS compound, and the other PFAS compound, basically it stays the same. So remember, these are the only 2 we know something about, and we have hundreds of them, which we can measure in human milk, and we have no clue if this is the same or not. Probably not. There must be a few bad guys in there, or women, whatever you want to say, but we still, this is the top of the iceberg, to tell you the truth. Okay, I basically already said all this because of the time. I don't say much about it, but the one thing which I really think is important for PFAS is, if I'm doing my animal experiments, and if I'm doing my cell experiments to get an idea about mechanism, I want to be sure that the mechanism is similar in humans. And what this table actually say is that if you look at the epidemiology, the human data, and you compare it with the animal data, there's a good resemblance. And we call that biological plausibility. In other words, I can trust my animal experiments or my cell experiments to make predictions for humans. And that's important to do. Because sometimes you have rats which respond completely different from humans. Could also be the other way around. I don't know if anybody of you ever heard of Softenon, but Softenon was something pregnant women got because they were vomiting, etc. They felt lousy. And it turned out that all these children were handicapped. And this was something which wasn't picked up by rat, mice, monkey, or rabbit studies. And look, it can't be 100% perfect. And we will always make, it's not even a mistake, but humans are not animals 100% sense, right? Okay, then the chicken. Interesting enough, the Dutch government didn't want to do much about it. There were some initial indications, and then the NRC, and I have very good contacts with quite a few science journalists, both in the Volkskrant and NRC, and they asked me, can we do a, let's say, a kind of study to see if something is going on or not. And so they paid for themselves the first egg analysis. This is a newspaper, not the government, not RIVM. And they did the analysis, they paid for the analysis in an engineer office laboratory. And they found out that there were levels of PFAS, especially 1 or 2, which are important, we know much about. And then they gave it back to me and they said, okay, we got this. What do you think? It was very straightforward. These levels were too high. You know, this is not acceptable. If you would be a child eating 1 or 2 eggs a day from these private chickens, scharrelkippen, this was clearly above the level which was acceptable for these type of compounds. And thereon, you had a situation, and by now, the Dutch Food and Safety Authority, RIVM, have done multiple studies. And this is what it looks like. Now, all the red and black ones are around the limit which is acceptable or above the limit, while actually the green ones are okay. Now, you will say, okay, there are enough green ones there. But for me, this is really a problem, because I would have seen preferable a very restricted area where the levels are too high. But if you look at the black, the green, and the red ones, it's distributed all over the country. What can you do? Where does it come from? No clue. So you can't tell Chemours, actually stop with it, or 3M, because there is no cluster here in this part of the country. Yeah, so we just don't have a clue. And the only sensible thing RIVM could do at that point, and I fully support that, is say you should limit the amount of eggs which you eat from your private chickens. Because we can't predict where it's coming from, and we can't predict if you're having eggs from your private chickens which are too high or not. They couldn't measure all the chickens in the Netherlands, that's ridiculous. But we know that chickens which you buy at the supermarket have much lower levels. And it most likely has something to do with that they're not outside too much. And they're part of the food chain if they forage outside the stables. Okay, I think I said enough about this. The problem is that already the eggs are causing levels which are above what a toxicologist would be finding acceptable. But PFAS are not only there. It's in meat, it's in milk. Actually, in some situations, it's even on all kinds of vegetables because it's coming from the air. So this is only part of the background exposure through food. So if you already exceed it with eggs, and you get even more, you exceed it even more from other food sources, that's inevitable. And we know it is. And we know it happens like that. So there is justification to say, limit the eating of the eggs from private chickens. And this is especially true, I think, for children and pregnant women. If you ask me until what age, 10, 15, or something like that, because I want to be sure that it's actually also covering the area in which you develop from child to adolescent into the puberty, because I don't have solid ground for that, but based on my broader experience, I would say adults take a couple of eggs a week, you know, it's probably not a big deal, because the cancer from PFAS is not a big deal. If you get cancer from PFAS, you get it at very high concentrations, which are normally found in occupational settings, factories, etc. But you and I, which are sitting here, don't worry about cancer from PFAS. That's, I'm absolutely convinced. Okay, pesticides, last topic. Can it still be done? Yeah? Okay. Pesticides, another one. You may have heard all kinds of court cases about people living around lily fields. And they were exposed to much higher levels because in the agricultural situation for lilies, they use tremendous amount of pesticides. And we're not doing anything with the pesticide, with the lilies in the Netherlands. That's ironically. We send them to Saudi Arabia and to China. It's pure luxury. But the amount of pesticides introduced into the environment for this type of agricultural activity is ridiculous. You have no idea how much it is. And the people living around these lily fields, which are increasing because the farmers, they can earn much more money on it, you know, they're worried, and so they should. Because their houses, and I've seen that, if they have been spraying, then on the windows and in the garden, you know, there is a greasy layer from the liquid in which the pesticides are actually containing. They contain the pesticide, meaning that they're exposed. We know that they're more exposed. And if you look at food, and that is this one, and you don't need to read it, but look at the little red ones, and the yellow ones, and nothing. Only the red ones are the ones from food, strawberries, or mangoes, or something like that. And if you look at that, you see it's very limited. Okay, within the EU, they did a couple of 100,000 samples. And they found that in 3 to 5%, there was an exceedance of the acceptable daily intake. And you have to realize that that could be the little box of strawberries or something, which you eat once. But these calculations we make for lifetime exposure, daily uptake. Meaning that if you would eat that box of strawberries every day, and you would do that for about 70 years, you may have a little problem. But I guess if you eat that many strawberries, you may get other problems too. So, in all reality, we have vegetables and fruit in the Netherlands which are usually okay, to say it shortly. The majority of the exceedances in this acceptable daily levels, which is called our maximum residue levels, are also coming from outside Europe quite often. Because in Africa and South America and in Asia, they're allowed to use other chemicals for pesticides. And that means actually that they may be above a level, or there may even be chemicals there which we're not allowing anymore because they could get cancer. But again, they could get cancer if you at that level eat it every day for 70 years. Oh, this is the Netherlands. The previous one was, and here you see what the exceedance is in the Netherlands. Is the little dark green bar here, and this is above the level. So again, in the Netherlands there were about 3,000 samples. Again, I would say, don't worry too much about fruit and vegetables and pesticides on that. Because there are quite some organizations which say pesticides shouldn't be there. I agree, but not for human health. I agree from an environmental point of view, because we're a very small country, we have a very intense agricultural situation, we use way too much pesticides for this situation, and the impact on the biodiversity and food chain, to my humble opinion, is much more serious than any risk from fruit and vegetables in the Netherlands, because there's some pesticides on it for humans, to tell you the truth. So, in a way, it's good news and bad news. This is what I just told you. And of course, the most vulnerable group is the pregnant woman again, and the baby, the first years. And that's important to remember, but by now I think you got the message that that is a sensitive period. And it's interesting because we had this situation, and I think it was either Zembla or something, they interviewed me, and they came up with baby food. And baby food, turned out, shouldn't have any pesticides in there, not measurable at least, meaning much lower than the levels we're talking about. That's a restriction, otherwise you can't sell baby food. Now, there are plenty of mothers who think, well, I don't want to give my child only baby food from a little bottle. So they're going to buy fresh fruit at the grocery shop. And it turns out that that is actually, according to the same regulations, an exceedance, because the children shouldn't be. Well, that's stupidity. How could you say on the one hand that a little bottle, which is probably less healthy than natural fruit or vegetables, shouldn't contain any pesticides, while on the other hand, if you go to the grocery shop and you want to give it to your children because you think they're healthy for vitamins or whatever, suddenly you expose them to concentrations which otherwise wouldn't be allowed. And I have no idea what kind of stupidity in the ministries there was when they set that rule, or in Europe with the European Food and Safety Authority, because this is such a controversy. And it was an easy go for me on television to say, well, if I had connections with a pregnant mother or a child, a baby or a young child, and the mother would ask me what to do, I would say, well, I can imagine that you want to buy fresh fruit because there are all kinds of profits besides little bottles. Buy biological. So at least the levels are lower. So that was what I said on television, and they were pissed off in The Hague. When I said, okay, the children should, preferable at that age, somewhere between 1 and 5, should preferable eat biological if they're not eating it from the little bottles. And I thought it made complete sense, but from an agroeconomical point of view, it wasn't such a clever thing to say, apparently. But I don't care, because I'm not a government official. So that's the advantage of being a professor, and more an advantage if you're an emeritus, because you don't have a boss at the university who can say, can you lower down a little? What about diseases from pesticides? Quickly, Parkinson. Is it true or not? This is the Parkinson situation. And here again, you get this graph. The green line is nothing is going on. All these studies are showing that on average, they're on the right side, meaning approximately a 50 to 100% increase of risk for farmers. The proof for Parkinson, in this case, is actually mostly for occupational exposure. Farmers spraying pesticides. And the other thing is, and I fully support Bas Bloem from Nijmegen saying that we have to be careful, but we also, with epidemiology, look backwards. We look in the mirror back. Because what actually happened was, Parkinson, you don't get it, if you spray today, you get Parkinson tomorrow. You get it after 10, 20 years. And there were completely different pesticides used at that time in the Netherlands, which are now taken off the market. So they may be old. But the problem is that we don't have good testing systems to say if the new chemicals are safe. And that I support Bas Bloem, who's a professor in neurology there, fully by saying, look, as long as we don't have good test mechanisms, you should be very careful. And you should develop these test mechanisms. They've been talking for that for the last 5 to 10 years. They probably spent more money on their meetings in Italy or any other country of the EU, which they better have spent, could have spent on research, and developing techniques. But they're still talking. This is neurodegeneration, and it goes beyond Parkinson. Because again, the same type of graph, and I hope you excuse me that I use this graph, because it's for me the only way to illustrate it. Again, you see that from the standard situation in which nothing happens, which is 0, 2 is 100% increase, you see that for Parkinson, Alzheimer, and ALS, we have quite some indications that pesticides are actually causing it, at least in occupational settings. What I can't prove from dose-response relationships, if actually you and I, background people, are also at risk. Honestly not. We don't have sufficient knowledge about how much the dose must be to get some risk for these neurodegenerative diseases. Okay, then the last one, exposure studies to pesticides. You have another phenomenon, not only neurodegeneration, but also neurobehavioral, neurodevelopmental effects, meaning ADHD, IQ, autism, etc., etc. And here you got a number of studies which have been done, and this is mental development, psychomotor development, attention, ADHD, something like PDD, I can't remember for what the abbreviation is. In other words, all the arrows for these chemicals are going down, meaning that there is a decrease in motor development, IQ, attention deficits increase, etc., etc. We know for sure that pesticides, and not only the old ones, are actually causing neurodevelopmental effects. Children living near agricultural areas, because the parents are farmers, have been proven to have lower results at school compared with the ones which were living farther away from these areas. And these are still chemicals which are also modern. And where it stops, honestly, I don't know. At least 3, 4, 5 years. If it's 10 years exposure, I don't know either. But the pesticide exposure in child development is a really important aspect. And this is also something in the Netherlands which played. And we had this situation with lily fields and people living around it. And we had a court case. And this is just to show you how much they use for lilies. This is the use of pesticides 12, 16, 20. And if you compare that with apples, pears, etc., it's about 1/3. So this is a luxury product, which we actually do only to keep the Arabs and the Chinese happy, to tell you the truth. So you can wonder if we really need to do that. Okay, so the last court case, which we won, by the way, I was the expert giving the expert opinion against the opposite side. Of course, the lily growers, the agricultural side. And I argued that there could be 20% higher concentrations of pesticides in houses, which was measured. 250 meters from an agricultural area, I started to see some decrease based on literature. You had neurodegenerative diseases as well as neurodevelopmental diseases. And there was a large number of epidemiological studies saying that, look, these neurodevelopmental diseases are real. And in animals, we see them too. But again, if we bring a new pesticide on the market, or we have to re-register a new pesticide, in general, the European Food and Safety Authority doesn't require any studies with neurodevelopmental effects. It must be really serious if they want to ask it. So it's going very, very slow to say both do good experiments, like Bas Boon says in Nijmegen, for Parkinson, and I say that for neurodevelopmental studies, before you admit another pesticide to the market, to be sure that it doesn't influence the situation. Okay? We're very modern. The Netherlands, luxury problems. And I only want to say with that, we're a very tiny country, and I have to say this, you know, as a kind of disclaimer, because I work for the World Health Organization and the Food and Agricultural Organization, FAO. And if we look at it from a global perspective, our problem is nothing, to be quite honest. Because if you look at the factors, the insect factors, which are causing diseases, and are not causing diseases because from a global point of view, pesticides are used, there is a tremendous benefit. And this is just mentioned here. You have to remember that malaria and we're making progress here, but the malaria, 30% of the world's population is at risk. 500 million people get malaria. 1.7 die from that, mostly children. If you look at dengue, which is another disease, which you are actually at risk when you're going to travel to Indonesia, Bangkok, etc., because it's in cities and they sting during the day, 2.5 billion people are worldwide at risk. 20 million cases in 100 countries, tens of thousands get a serious hemorrhagic fever. I don't bother you with that, but you die from it. Meaning that we are a little country with a luxury problem. We earn money on lilies for Arabs and Chinese. We have a very intensive agricultural system in which we use relatively high numbers of pesticides, quantities, on very small areas to be as productive as we can. But we're a small country. But from a global point of view, if I would give a talk about that, it would be completely different. Because actually their pesticides save lives, really save lives. Okay, so maybe there are some children from some African farmers who have 1 or 5 point loss in EQ. You can be very egoistic or egocentric and say, what does it matter? You know, as long as they live. Otherwise they would have died in the first 3 years of life because of malaria or maybe dengue. So that's the balance you work with, if you look at it from a global point of view. Finally, I'm getting so tired of this. If you look at it, now we have the knowledge. People have warned the governments, US, Canada, etc., etc. And to tell you the truth, I call it slow turning mills. It's a translation from the Dutch, langzaam draaiende molens. And I'll give you this scheme. And this is a scheme just to illustrate how things go in real world with politics and economics. In the 60s and 70s, we had DDT and chlorinated pesticides. In the 80s and 90s, PCBs, dioxins. Then 2000, the brominated flame retardants, also persistent. They were in your television, for example. And then now we have PFAS. And the interesting thing is that for most of it here, I was still relatively young. Okay, so I can't remember it personally too much, but this situation I remember. There was academic research, trial and error. They found things which people didn't like, the scientists didn't like, the toxicologists didn't like. Then this new toxicological information went into congresses, publications, etc. Did governments respond? No. There was confidential toxicological information which was often not shared with academics and independent researchers from companies. Then the connection with the government was clear between the industry, on the one hand, chemical industry, etc., and government. And then, first of all, you see there's a state of denial in which you say, we need more research. That's the cheapest argument you can get. You know, if you don't want to do anything from a political point of view, economical point of view, they probably have a book in which they just open page 1 and they say we need more research. So yes, we need more research. And when they do more research, they say, that doesn't look good. We have to repeat the study, now by another laboratory. Then they say, well, the study you've done is not completely standardized. We have to evaluate that and say standardization is the norm. And finally, you can always have the discussion if an effect is relevant in a rat compared with humans. And then about 5 to 10 years later, you will see that governments are taking restrictive measures, are actually reducing the production of all these chemicals. So here we have a line from the 60s to 2020s. And that's why I say, do we ever learn? I don't think so. Why? Because in the end, economics and politics, which are closely connected, are still important enough to delay any steps. And we now have the situation with PFAS in which we slowly say it has to get less. We have the situation with endocrine disruptors, in which we're still discussing if something is a hazard. In other words, just an effect without having the right dose level. But we're still working on it. And I can tell you now that within 3 to 5 years, you will have another group of compounds. And this scheme for me will be the same as in starting in the 60s and 70s, unfortunately. But this is how a democratic system works. Yeah, that's it. Thank you.
Thank you very much for the enlightening presentation. I think maybe if you have some questions, maybe we have time for 2, 3 short ones. If you really have a burning question you would still like to ask. No one? There? Oh, yeah. It's for the recording.
Ja, absoluut.
Ik begreep het onderzoek over wat kanker veroorzaakt en ander onderzoek niet. Ik had de percentages, dat het een heel klein percentage dat geeft op kanker.
Ja.
En er staat ook een ander onderzoek tegenover wat ik niet helemaal begrijp.
Oh, nou kijk, stoffen die niet direct op het DNA werken, dan krijg je een bepaalde hoeveelheid binnen en dat gaat gewoon zo. En op een gegeven moment kom je op een niveau, dan gaat die omhoog. Dan krijg je dus een effect, als een soort S. Als je een molecuul hebt wat direct schade aan het DNA veroorzaakt, en dat molecuul dat weet de hele weg af te leggen zonder dat het afgebroken wordt in je lichaam, van je mond tot de nieren of de lever en daar in een cel komt, dan kan dat ene molecuul al schade aan die ene cel geven en dat kan dan een trigger geven voor die cel om op enig moment, en we weten niet wanneer dat gebeurt, kan 10 jaar later zijn, spontaan te gaan delen en dat wordt dan een tumor. Theoretisch, het is een theoretische aangelegenheid. Kijk, dat kunnen we nooit meten. Hè? Maar doordat je op een gegeven ogenblik de concentratie weet in een proefdierexperiment waarin 5 van de 100 beesten kregen een tumor, dat is 5%, ja, ben je natuurlijk vrij gemakkelijk in staat om door extrapolatie naar 0 te zeggen van, als ik nou ervan uitga dat dit een effect is wat relevant is voor de mensen, dan kan ik naar beneden extrapoleren en zeggen, nou, ik zie deze concentratie en dan verwacht ik 1 op de 100.000. Maar eigenlijk zeg ik 1 op de 100.000 ratten krijgt dan een tumor.
Ik denk dat het een beetje...
Ja, het is een... En dan hebben ze er ook nog zijn er allerlei meningen over hoe je die curve moet trekken. Of die helemaal recht moet zijn, of je een kleine dip nog zitten. Maar dat werkt wel zo. Ja, ja hoor.
Yeah, so you said, I think somewhere that PFAS, we don't have to really worry about the cancer.
Right?
So what is it that we have to worry about then?
The immunological effects in children,
Yeah.
which decreases the response from your immune system on diseases, and that has been shown by giving vaccines which have less effect, 70%, 20-30%.
Yeah.
That's one thing. And for adults, there is discussion if the effect on the liver eventually also gives a higher incidence of cardiovascular diseases.
Oh, okay.
That those two are, and cancer, only occupational exposure, to my view, has clearly illustrated cancer.
Okay, thank you.
Mm-hmm.
Maybe one last question. There was a finger here, or
There are two. We'll take him too.
Industry wants to protect their profit margins,
Yeah.
so they often push back at this kind of research.
Yeah.
I have a feeling they gotten better at that in the past decades. Do you have
Yes.
the same feeling?
I agree. And this is actually one of the interesting things is Roundup, glyphosate. They're becoming more open because it is actually not their honesty, their green feelings. Let me put it like this. Honesty is not the right word, but the green feelings. They know that if they got lawsuits and they have to pay billions, because especially in the US, they have to pay money if somebody gets cancer who was spraying professionally with Roundup. So they're becoming more and more careful that if they have a specific disease coming from their product, and it has been illustrated earlier in literature, the judge or the jury can say, you should have known that because there's publication there. So they're more alert, but basically if you address it, it's a financial thing too. You understand? Yeah.
Yeah, the question, now you more or less have to wait until a product is in the market and then test if it has some effect. Is it not possible to, from the experience you do, to get some kind of design rules?
They are. There is a very strict number of tests, mostly animal tests, which are required by the European Food and Safety Authority or the US EPA for a new pesticide. But the things which are now upcoming in literature, toxicological literature, is the Parkinson effect, neurodegenerative and neurodevelopmental aspects. And these tests are not standardized in the permission they're getting. And we argue that knowing what we know now, these tests should either be developed quickly, because not of them all are available, or should be done as a kind of restriction before you bring it on the market, or even when you have a re-registration thing, because every 5 to 10 years a product has to be re-registered. And that happened to Roundup, glyphosate. It had to be, well, this was a battle up to the Senate, the Tweede Kamer. Was it carcinogenic or not? And this was a lot of money, a lot of industry, a lot of green parties. It was a kind of Waterloo, and I'm still not clear who lost, because it's not over yet.
Thank you.
Yeah.
Thank you. Yeah, I think we have to end it there because we're a little bit over time already. Thank you so much again for the presentation, and have a nice evening, everyone.
Okay.